Yes, sir. We are in live now. So, yes, sir, can we start, sir? Very good morning to all the participants. And it is a great pleasure to have you all here for Knowledge 4.0 webinar series, which is one of the unique initiatives of Chennai Institute of Technology under the guidance of our Honorable Chairman Sri P. Sriram, a successful first generation industrialist and managing director of MK Group of Companies. Under Knowledge 4.0 series, we have been conducting webinar series such as technical webinar series, research webinar series, alumni webinar series, career guidance webinar series, and innovation webinar series. And today we have technical webinar series titled Technology Trends, Disruption and Opportunities, which is going to be handled by Mr. Ganesh Raju, Technical Lead, Big Data and Data Science, Linaro Data and Cloud Group USA. And Chennai Institute of Technology was established in the year 2010 by our Honorable Chairman Sri P. Sriram, and now our institute is being ranked within 10 institutes among the top 10 institutes among the private engineering colleges in Tamil Nadu. And it is a great pleasure to introduce our guest speaker, Mr. Ganesh Raju, who is an accomplished digital transformation leader. And he is very passionate about technology and likes to keep abreast on latest trends in technology. In his 25 years of experience, he has founded a couple of technology companies, led various technological transformation for various companies, serving wide range of industries. He also possesses business knowledge and proven technology transformation delivery track record in oil and gas agencies, healthcare, insurance, e-commerce, semiconductor, and information technology industries. Throughout his career, he has filled in various executive and management roles, and he is reckoned as IoT, big data, machine learning, and cloud technologies expert. In his recent role, he is involved in various open source big data and data science, machine learning, artificial intelligence technologies. He is leading Big Data Open Source Consortium (ODPI) and also contributes to multiple open source projects Apache Hadoop, BigTalk, HBase, etc. And now I'm very happy to hand over the session to you, sir.
Thank you, there, Lakshmi, for the introduction, and thank you to CIT for giving an opportunity to present this. I'm excited to have this opportunity, and today's topic is about technology trends, disruption, and opportunities. I hope this talk is giving all the students an idea what is happening in the technology currently and what they can foresee in the coming years, and hope so that helps in their job opportunities going forward. So, for a little bit bookkeeping. So, during the presentation, I will pass every few slides to encourage all the audience and the students to ask me questions. So, please do post your questions in the chat room, and every few slides, I will pass and look at those questions and answer as much as I know. And then we will carry on. Once the session is over, then we can open up for more questions. Okay, to start with, just to give a brief introduction about myself. Like Dhanlakshmi said, I work for a company called Linaro, and I am a team lead where my focus is on big data and data science. I was born in a place called Rajapalayam in Tamil Nadu, and from there I moved on. So I just realized I didn't share the screen yet. So let me go ahead and
Yes,
share
sir.
the screen. So that's the screen. Okay, sorry about that. Um, okay, so that's me, and I was born in Rajapalayam, a place called Tamil Nadu, and I started my career as assistant manager in Pentafor. I started working there from 1994 to 98. My career started in the graphics world, and from then on, moved on to software and IT, and I moved to US in year 2000. Since then, I've been living in Houston, Texas. Um, in US, I have been working as enterprise architect at various companies spanning various industries. I work for oil and gas companies like KBR, Halliburton, ExxonMobil, Schlumberger, and many others. I work for IT companies like HP. I work for insurance companies from like Azurion, and I work for medical healthcare industries like Blue Cross and Blue Shield. During my career, my role has been to go in to an enterprise, study their existing infrastructure, and look at their existing technology stack, and as a digital transformation advisor, advise them how they can take on to the next stage in technology, how they can improve, and what changes can they bring into their enterprise. I've been with this company called Linaro since 2015. Um, yeah, I've been doing various things while working at Linaro. Like I said earlier on, I've been focusing on some of the big data technologies, and I am a contributor to open source projects like Apache Hadoop, Apache HBase, Apache BigTop. I'm talking about certain keywords here. I said I'm a committer, and I'm also talking about open source. I'm quickly going to explain that. Hold this in your mind, and I will explain what open source is, what committer means a little bit later on. I'm an open source advocate. I'm also involved in a project called ODPI, where I'm a technical steering committee member. This ODPI is a consortium of many big data companies getting together, like IBM, Pivotal, EMC, um, Capgemini, and many others. And I lead some of the technical decisions that happens on their big data stack for those companies. My expertise has been again big data, IoT, cloud, and machine learning. So that's about me. I would like to also give a brief introduction about the company that I work for, so you understand what my daily role is. And I also will explain how I fill in that role, how that helps the society and the community in the software community. I mean. So Linaro is completely involved in open source. Whatever we do in Linaro is all open source. Again, I will explain what open source is real quickly. Um, and Linaro is an engineering collaboration company. What that means is Linaro was founded by many companies like ARM, IBM, Samsung, Freescale, High Silicon, all these major companies getting together to work on one common goal, that is open source technology. So if you think about it, these companies are actually, some of them are competitors to each other. Each individual company actually works on some kind of open source technology, and end of the day they realize that they work on similar open source technology, and they realize why to um, waste their efforts on working on similar thing. Why not we collaborate and work as a common goal to contribute to the open source community, and that's how Linaro was formed. So the currently Linaro's members are companies like Arm, Google, Facebook, Huawei, Qualcomm, Fujitsu, and many more. As a company, We are a top contributor to the Linux kernel itself. We are one of the top five contributors to the community, the Linux kernel. And we also focus on ARM ecosystem. I will be explaining what ARM is a little bit later, so keep that as well in your mind. So we focus on ARM ecosystem. So the company is by focus area broken down into different departments. One is artificial intelligence, one is autonomous vehicles, one is consumer mobile, and another is OS, data center, um, edge, fog computing, high performance, and high performance stands for supercomputers, IoT, and multimedia and security. So, what is actually open source? Open source means the source code is openly available for the public to see. So, the public can see the code. Actually, they are given the rights to edit, modify, and actually also add new features if they would like to. So, this encourages collaborative development between the community. So, you may be asking why someone writes a application and then open sources it. So the idea is, one single company cannot write, a perfect software. So once you open source it, there is more potential for the community to notice the bugs in a software, and chances are they could fix that bug, or you could even get some free contribution from the community to enhance the code itself. So open source development has two models. One is cathedral model, and another is a bazaar model. Cathedral model is when a company develops a product, finishes the source code, and releases the source code as an open source code at the end of the release. Bazaar model is, you start open source in a collaborative manner, opening up the code from the beginning, from the scratch, and you work with the public as a collaborative way. So the code that anyone contributes or is called anyone that freely gives, or the code changes or new code that anyone um, provides is called a contribution. So open source is more like a karma based, where the people contribute towards the code, and based on their contributions their ranking in the open source community increases. For example, when you're contributing code for the very first time, you're called a contributor, and the more code you contribute, you are awarded and you raise up the rank, and you're called committer. And the more you even more code you contribute to the source the community, you from committer you become a maintainer. So that means you start to maintain the whole project. And when you get to a level where a lot of code is contributed by you, and you start to set roadmap and strategy for the whole project, then you would probably become a lead maintainer when you can define how the project is directed and things like that. And a lot of times these open source contributors are well known in the community. Many large enterprises look at the quality of the code they contribute, and actually hire those open source contributors. Um, And the last thing is, open source doesn't mean that it is a free software. It is a open code, but doesn't really mean it is free. It might be, but not always. So open source does have a licensing, and the licensing depends on how you utilize the code. So it is freely available for you to look at the code and modify it, but how you use it, you may have different licenses for that. So recently, open source has becoming popular. Like I said, how many times you have heard a proprietary company being hacked, and you realize that millions of credit card company data has been exposed. There's been a security breach. So by open sourcing it, you are actually giving the code away so the community can see it, and you're reducing such risks because community can notice this bug and probably can fix it earlier on. And not only that, this also gives confidence for the public if they can see the code. Most of the proprietary code is not visible. Proprietary code is also called as closed source code. Those are not visible to the public. You never know what happens inside Microsoft Windows operating system, what code is in there, if it is really actually taking your private data or not. You never know. But you could go through the open source code and know exactly what is happening inside it. So, like I said, corporates can use and get benefit of free contributions from public, and thus reduce their investment on building the software. And a lot of times, a lot of projects, open source is actually a fundamental, foundational block for many of the proprietary softwares. I'm going to give you an example how that looks like. So there are millions of developers currently in open source and who are actually working full time on contributing this. 95% of my company is actually as a remote, and that's one of the benefit for open source. Most of them work in from remote. So these have been the benefits of open source, but there is also a disadvantage. That is, open source may not have the same kind of support that you might get from a enterprise proprietary software or a closed source software. So we spoke about open source. Some of the examples are Linux. If you're familiar with it, Linux is a popular operating system which is open source. Android, which is a lot more popular. Most probably, everyone has this Android in their phone. If you have Android phone, which is open source. And GitHub and GitLab are repositories of all this open source code. 99% of Fortune 500 companies now use open source code. There are 140 million open source projects that are available in GitHub alone. In that, 50 million was added just last year in 2019. So there are 40 million developers currently in GitHub. Now, Red Hat, if you're familiar with it or heard of it, is the first company that built a business model based on open source and became really successful, which recently got bought over by IBM. So now, not just the software, even hardware layer is actually done open source. There is, for example, there is a project called OCP, Open Compute Project, which is led by Facebook, where they have started to design hardware and open source it. So this is one example how open source can be at the fundamental building block level compared to many other projects. So here is an example Apache Big Top, to which I am personally involved in, is at the fundamental block. On top of it, you can see many companies have built their own software like Hortonworks and Cloudera, IBM, Pivotal, EMC, AWS. They all have this big data suite or big data solution that is built on top of Apache Big Top. By the way, Hortonworks and Cloudera has been merged, and is one company now. Just a side note. So these companies, they utilize this open source code where they get free contributions from millions of developers, and then they take it and build a proprietary software stack on top of it, most probably a UI user friendly stack on top of it, and then they use that to monetize, make revenue out of it, and also provide support on their proprietary software. So you may be thinking, can I get paid doing open source? You probably can. There are so many millions of developers who do just open source, and companies hire them to do the open source. You may be thinking that they don't directly contribute to the company itself. All the code that they write is going to be open. It may not be just for the company that they work for, but it could be for just the whole industry. So these are some alternatives for the proprietary well-known software, and the alternatives from open source side. The Windows operating system has an alternative as a Linux operating system. iPhone, which is iOS operating system, has an alternative as Android. And browsers like Safari and Microsoft Edge has alternative open source browser solutions like Firefox, and so on and so forth. So we spoke about open source. Dhanalakshmi, if you could post the first poll, I would appreciate it. Meanwhile,
Uh, yes, sir. So I posted that, sir. First poll.
okay, awesome. So you can,
Oh,
the attendees can look at the poll and put your vote, and based on that, I would like to know how many people are aware of open source, and so that gives me an idea. So moving on, I'm going to talk about ARM. So ARM is just like Intel, which is a lot more familiar as into semiconductor industry. The difference between Intel and ARM is Intel manufactures its own chip. ARM doesn't. What ARM does is just designs the chip that goes in your cell phones and your laptops and your computers. And what it does is it opens up for ecosystem of hardware vendors like, for example, Qualcomm, Marvell, Broadcom, Huawei, HiSilicon, those folks to manufacture the hardware. So even iOS or the iPhone has ARM chips in it. The chips that is manufactured by Apple has ARM licenses in it. So every iPhone or even Android phones which has Qualcomm chips is actually an ARM chip. So they pay the licensing fee for the design to ARM. So 70% of world population actually use ARM chips currently. There are 155 billion ARM chips till date, and over 25 billion just in 2019 were shipped. So there's a difference between Intel and ARM. Intel is the manufacturing leader, well known, which is dominating PC market and data center and high-end supercomputers. ARM, on other end, is a leader in mobile. Pretty much every mobile or every iPad and laptops, and they have ARM technology, ARM chips. It is ARM is mostly, like I said, a ecosystem of many vendors, and they focus on open source primarily. And another big difference is Intel is CISC based and ARM is RISC based. So I don't want to go in too much detail on that. If you are interested, you could do more research and learn about it. So coming to the main topic, technology trends. So right now, then let's me if you can post the second poll, I would appreciate it.
Yes, sir. Yes, sir. I'll do it.
So coming to the main topic, I would like to categorize into three sections. First is leading edge. That means what is happening in technology field right now. What are the disruptions happening? What is the most hyped technology? What technology has the most jobs? So I'm going to cover that in a leading edge. I'm not going to talk about any of the past technologies. The focus is what is happening currently and what can get you a job today. So that is leading edge, and cutting edge is something that we foresee in next 3 to 5 years. So the technologies that might come in next 3 to 5 years, if you plan to get on job, you probably should already know what is there in the leading edge. And if you are planning to find a job in next 3 to 5 years, you probably should focus on what's in the cutting edge. And the bleeding edge is beyond 5 years. So those are very advanced technologies, very early stages. We are just learning what they could be at the moment. So those are bleeding edge. So some of the technologies currently, which based on what I know, what I've noticed with my experience is these are the ones on the operation sides. RPA. RPA stands for Robotic Process Automation. So basically, they are tasks, scripted tasks, programmed tasks, which are automated based on a sequence of steps. Um, so it is the idea is to simulate human behavior, and it is just to automate a certain number of steps. It doesn't have any AI or artificial intelligence built in. These are just scripts. So example could be, um, you know, let's say there happens an accident and someone wants to call an insurance company and wants to file a claim. So there could be RPA process that listens to the call, gets the policy number, the name, and the accident location, what kind of vehicle, and things like that. And it could automatically go ahead and create a claim and also allocate adjuster for the claim. And it could send all the necessary documents and the emails to you, all automated way. So again, RPA is a program. It's a scripted program. Nothing. It's not actually a robot, as the name suggests. There's no walking, talking robots. There's no physical machine. So there is no AI yet. So these are the top RPA companies and technologies that's leading in the industry right now. And the next technology that's trending right now is microservices. So earlier days we had this monolithic application where you have various blocks where you have UI, the presentation layer, business logic layer, and data access layer. Nowadays, this concept has changed, and microservices are small, minute, self-contained services where now it you break up this monolithic into smaller self-service, and it gives you more flexibility, and that's the concept going on. Other technology is DevOps and container technology. If you're familiar with Docker and Kubernetes, um, in olden days, when you had to send an application to production, you would request for a server, and then you probably would get a VM, because there's you never you a physical server could host multiple VMs, and you probably would get a VM where you would host an application. This concept has changed, and nowadays industry is following container based deployments, where you could have small self-contained containers, and it's easy to deploy. So the difference between the VM based architecture and the container based architecture is, in VM, you would have infrastructure, the bare metal, and then you'll have a hypervisor, a layer on top of it. It's hypervisor as a software layer on top of it, and then you would have VMs built on it. Each VM would have a guest operating system. So multiple VMs, each one would have an operating system, and on that you would put your application. With Docker, you will have your infrastructure and then your Docker runtime, and one operating system, and in that you'll have a separate containers. These containers will not have operating system. These are much more lightweight and very quick to instantiate compared to VM. VM might take longer compared to containers, and these are quick to instantiate, quick to destroy. Big data has been in a trend last few years. The technologies like Hadoop, HBase, Cassandra, and this is a hype cycle from Gartner that, if you see, um, that big data is somewhere here. So the last few years, the big data was on the top, and now it's slowly going down. And what is it? The hype is more data science analytics. So the data science is at the top, at the peak right now. So if you're looking for a job, this is at the top. It may not be in the next 3 to 5 years, but at the moment, this is at the top. So graph analytics is at the peak as well. The languages at the moment that is in the hype cycle and top peak demand is Python and Go, and something new on called WebAssembly, which is assembly level coding for browsers, which has been catching up in the industry as well. So these are the things. If you're not familiar, please take a note and do your research. And if you're not familiar, please learn about that. And moving on to the cutting edge, this is what I was talking for next 3 to 5 years. NLP. NLP stands for Natural Language Processing. It does object recognition. It could do text recognition, audio recognition, and facial recognition. So NLP is actually part of the whole big AI category, and AI is a big ecosystem where you have machine learning technologies, and underneath it you have deep learning, and NLP is somewhere there, and that's what we are seeing in the next 3 to 5 years. Whole, if you see the industry, it has not yet matured in the AI. It is still in very infancy level. So the things like NLP is what is getting mature at the moment. So with NLP, you could do image recognition, face recognition, text recognition, and audio recognition. So how that works is you would provide this NLP tool, setup. For example, image recognition. You would provide a set of images, and you would say give a features of it or characteristics about that image. So for example, you might give a picture of a cat, and then you would say the NLP tool that this is a cat, and you start providing it thousands and thousands of picture, and then you keep saying, no, this is a cat in a different angle, and this is a cat in with a different background, and this is a cat in different position, and things like that. And slowly, what NLP would do is it breaks up into smaller molecules and learns from the feature and starts recognizing, okay, this is what cat looks like. And once you do that, you have a model. That's the model is what a learned portion of the NLP, which looks at the image and now it knows what that is. And now you take the model and use that to even predict in the future. So you could send a new picture and ask NLP and say, hey, is this a cat or a dog? And NLP would be able to recognize, okay, based on what it learned, okay, it's a cat, or no, it's a dog. Okay, augmented analytics. So, augmented analytics is basically doing analytics based on VR and AR, virtual reality and augmented reality. So, this virtual reality and augmented reality technologies have been growing recently, and in the future, you would be able to start doing data analytics based on virtual reality and AR. Hyperautomation. This is basically a RPA with AI built on top of it. So RPA is the robotic process automation that we spoke a little earlier. So where you have task automations, where you have codes and everything scripted out, and a workflow defined, and it is automated. So from there, you will slowly move on to process automation. And what we are talking about here is hyper automation, where you will have AI and machine learning algorithms built in and used for the process automation. So here in the process automation, you will also have chatbots, smart speakers like Amazon, Alexa, Google's own smart device, and things like that, um, to get to the hyper automation. The next thing is IoT, Internet of Things, or you could call Edge. So both mean the same. So this has been picking up lately, and next 3 4 years, you will see a lot of technology development in this area. So it is predicted that over 1.1 trillion dollars will be spent on this IoT technologies by 2025, um, and there will be over 25 billion devices by 2025. Um, sorry, 50 billion devices by 2020. These will be the smart devices, um, and this is growing. And um, edge are actually, are the IoT devices, are have not seen, are devices that is a visiting card size. And if you can see in the camera, I'm holding an IoT device, and these devices are so powerful now. It has multiple processors, 128 gigabyte RAM in it. It has USB SD card, and it can run in battery, and you still have even smaller devices which has this compute power and memory built in. So these edge devices are becoming more and more powerful, and more things can be done in such a small devices. Going forward, you don't need a huge computer or a server anymore to do a lot of processing. The next thing is fog computing. I know many of you would have heard about cloud. Fog is a new concept. So fog lies between actually edge devices or IoT devices and the cloud. So with the cloud getting mature now, many enterprises already use cloud technologies, There is a disadvantage of cloud that the cloud are actually data centers where you have hardware machines sitting few hundred miles away from the enterprise. So there is always a network latency between your on-prem enterprise computers users to the cloud, and cloud charges for each network data back and forth. So it could be the cloud could be at some point very expensive, and it could also have the network latency problems. So now the new concept called fog computing, which is micro data centers, are getting built, which could be closer to many of the enterprises, and in the future, the applications would be smart enough to um, know where they should run their workload. For example, if an application has to do a task, it would know, okay, this task takes minimum amount of compute, minimum amount of data, then it would be able to handle that in the edge device or IoT device. And if it would take a little longer processing time and little more data, then it would be sending it to fog computers, fog data centers. So fog data centers are not the whole big data center which takes a lot of real estate. These will be small boxes or small boxes that like a vending machine that will be closer to enterprise. And the application would be able to send their workload to the fog. And if the application needs a larger processing and a lot more data, then it will be able to send it to the cloud. So in the future, application programming languages and the technologies would automatically handle this. And the next thing is HPC, which is high performance computing or supercomputers. Supercomputers have actually started to become available in general for enterprises. Earlier, it used to be available only for large research units. Now it's become more cheaper and it's available for enterprises. And it is available in cloud like AWS and Azure and things like that. So enterprise can really utilize the performance of a supercomputer uh, by through cloud or directly buying them. So HPC could also have custom built CPUs, GPUs, and accelerators, which is actually happening currently. Um, you know, uh, some enterprises have workload specific chips. For example, they build a chip for certain type of machine learning, and for example TPU, which is a tensor process unit created by Google. So that's an example. So they could build such CPUs and put it on the supercomputers so that it performs optimum for that kind of workload. So HPC in general has a learning curve. It has its own file system. It has its own architecture. In the future, HPC and the AI technologies will merge together. A lot of AI technology will happen in HPC. So if you want like to learn, I would encourage you to learn what HPC is, what the how the architecture looks and things like that. Okay, at the moment, I would like to pass here and see if I have any questions. So we have covered quite a lot. We um, have been through. So before we go going
Yes.
to bleeding edge, let's go over the questions in the next minute and see if I can answer them.
Can I ask questions, sir, from the Q&A window?
Yes, please. Yeah.
Yes, sir. So, will new information technologies change financial risk management process?
Will new technology change financial risk management process? Yes, I think. the technology in general will affect every industry in general. Okay, so even including financial. So, for example, like I spoke about supercomputers, I spoke about AI. These things will fundamentally change how business is done. So I have a slide that will show and explain that, which will be coming up later on. So I'll go over it again when we get to that. Someone asked why they named it as fog computing. I think it is one level below cloud, so they called it fog computing.
So another person has asked, like, how does the machine understand the images fed to it?
Yes, I think I briefly explained. So how you do is, for example, the technology like NLP, where you provide this tool, okay, and say what that image is. And for example, you will provide a cat picture and you will say this is cat. And the tool, what it does, it breaks up that image into pixels. And it, from the pixel, it captures a lot of features that it tries to figure out. And then what you do is you send the tool thousands of images, of cat images. Okay, and then it compares between them and tries to understand, okay, oh, this is how the cat looks like. That's how you train.
Yes, sir. So what will be the future? That is, which technology will attain a high paid job opportunity for freshers?
Yeah, that's the reason why I split into three, leading edge, cutting edge, and bleeding edge. I left it to you to be the to determine when you want to get into a job. If you want to get into a job today, you probably should already know what is leading edge technology. If you want to get in job in next 3 to 5 years, you want to know what's in the cutting edge technology. And all the technology that I described are the topmost ones that will give you the best job opportunity with the best salary.
Yes, sir. So how can we ensure the security for open source, whether it can be hacked or not? If so, how can we find that?
That is the whole idea of open source, because the code is open. Anybody can go in and see what the code does. In the proprietary software, you may not get that chance because you don't know what exactly is written.
Yes, sir. So what is GPL and LGPL?
Those are licensing terms. So um, you could research it. I don't want to go in too much detail. Those are just different types of licenses. So basically, you some software will choose to be a GPA license, and the terms will define how the license fee will be charged based on the usage. For example, some software, they will charge you if you take their code, modify it, and put it on production. Before production, they may not charge you. So those are the terms. So it's just a licensing term.
Yes, sir. So we have so many questions. Can we take some more, or you're continuing, sir?
Okay, let me continue because we
Okay.
got quite a lot to cover, and then
Yes.
by the end we will come back to questions. And then
Sure, sir.
so the bleeding edge, that's what we are looking at beyond 5 years. Okay, so what my opinion would be, everything will be AI first, artificial intelligence first. Okay, all technology will be linked to AI. Even if you go and think about what we went through, all the technologies that we spoke till now has some kind of relation to AI already. So I think AI is a fundamental necessity for the future job opportunities. Okay, so the things like human augmentation. So now there are steps there that's taken by various companies like Google, Apple, Facebook, Tesla, to improve human capabilities by adding AI to human as an interface. Okay, so here is a small video. I would like to play this, and hopefully you can see the video. If not, then please let me know.
So we cannot hear the sounds. I think that is a little
Are you able to hear now?
yes, sir, now we can hear it.
Okay, so that technology was developed by AI. It's called Alter Ego, and there are many YouTube videos based on that. The person you saw is Arnav Kapoor, who has been working on this. So he has a headphone like looking like device where he has it attached to his ear, but he's not talking anything. um, so if you notice, he did not open his mouth. He is not talking anything. The device is able to capture what he's thinking from his brain waves, and it is already giving him, for example, he was asking what the time is, and it was telling him what the time is. He went to the grocery store and he looked at the prices. He wanted to add up the prices, and it was able to do that without him asking. So these kind of devices in the future could enhance the human capabilities. And this is just one example. There are so many companies already working on something similar. So Google has a project called Duplex and another project called DeepMind. IBM has a project Debater. So this IBM project Debater is very interesting one where they built a machine that can debate on any topic. So, for example, they did have a debate using this a few months ago, where they gave a topic to this debater, the machine, the AI machine, and then they had real people sitting on other side of the panel, and the real people knew what the topic was, and the debater was given just the topic, and the both were debating with each other, and debater was able to convincingly win the real humans. So you could actually see that video that is available in YouTube. You could research it and see that. So how the machine AI machine was able to do that is he had access to all the data. It was able to go research based on the topic, and based on what the panel was asking or putting the questions, it was able to figure out that, looking at the data, it was able to put the counter question and win the debate. So that's one project. And Boston Dynamics has been building robots, which is very smart. And Elon Musk has a project called Neuralink, where it's a project to embed a small microchip inside your brain to enhance its capabilities. So these are not actually future technologies; these are happening right now. And the commonalities between them is AI. And this is the hype cycle from Gartner. And if you see, these are all AI technologies. So, which is still starting to hype? They are not at the peak, they are at the start of the peak. So, that is why I put it in the bleeding edge. And if you can see, autonomous car, which is also an AI, has gone through the maturity already, and the things like automated drone delivery, cars like Tesla already drive by themselves. Those are already getting mature. And another technology that is coming soon is quantum computers. IBM and Google were able to successfully build quantum computers. For many years, people were thinking that quantum computers will never happen, but IBM and Google in last few years were able to build this. Um, in fact, Google announced that its quantum computer will be 100 million times faster than a classic computer that is available today. Um, IBM has been displaying its quantum computer in many of its shows, technology shows. Um, it's really, really expensive. It is still very, very infancy. Not many things has been tested yet. So the quantum computers work on something called qubits instead of bits in typical computers. And quantum computer is not going to replace the existing computer technologies, because quantum computer will be more focused for research kind of a thing. It may not be able to do good job in everything that normal computers would do, but it will definitely do excellent, way million times better job in certain things. For example, genome sequencing, figuring out for cancer genome sequencing and things like that. Quantum computers, once it matures, it will be having a big impact. And you may be asking, okay, how do I get to know more about quantum computers? There are already some courses available for basics of quantum computers, and there are already researchers available that you can go through and start learning. So, in the future, with AI picking up, there will be definitely a lot of industries that will be affected. Um, Newspapers, for example, magazines, agencies, and brokers, the middlemen, wherever there are, they will be affected. Things which can be automated will be automated. There will be definitely job loss, but at the same time, there will be also many jobs made because of the new technology. So it is, in a positive side, it is going to create a lot of jobs, and if you are in the right track, you will be able to utilize that. So this is a saying that I really like: digital disruption or transformation is about innovation, not optimization. What that means is, you fundamentally have to take anything and change from ground up instead of trying to fix it. Okay, trying to fix may not be an invention. Trying to change from ground up and recreating it could be an invention. So these are the technologies that will help in what we saw, the disruptions to happen. Things like 5G. 5G is going to have a major impact to our lives. Things like IoT that we already saw, HPC supercomputers that we already saw, autonomous everything. Things like I said, drones delivering by itself. Amazon already delivers packages through drones. During COVID-19, grocery stores were able to deliver groceries through robots to the house. Domino's Pizza has autonomous vehicle delivering pizza to people. So these are already happening. Uh, and AI, which we already spoke. So 5G will fundamentally change the society. There will be tremendous amount of growth in data. There will be a tremendous amount of growth in number of connected devices, smart devices, and the data rates are going to be 100 times faster than 4G. So 10 Gbps in your phone will be possible with 5G. Okay, so that is way better than your internet at your home. So the phones will have a super high fast internet service. There will be a lot more software defined and fine grained access. With the 5G technology, even the technology, the spectrum will be software defined. So even the signals and things like that will be software defined, and they will be able to fine grainedly control who gets access to what. Everything will be connected. There will be a lot more smart cities. The key, if you see, again, the key is AI in everything. So this is just a list of all the industries. This kind of answers one of the questions that we went through. So you have telecom industry, high tech industry, financial services industry, oil and gas, healthcare, automotive, transport, retail, and pharmacy. And based on the services, like service areas, marketing, supply chain, manufacturing, human resources strategy, how much impact they will have based on AI. And these are various subsections of AI. We spoke about RPA, robotic process automation, NLP, natural language processing. We spoke about computer vision, autonomous car. So those are the ones, and the companies, the process, how much impact they will have. So going ahead. So we had in the past cognitive revolution, agricultural revolution, industrial revolution. Last 10 year was digital revolution. And now going forward will be a AI revolution, socially, culturally, and economically. So now finishing up right on time. So just a quick recap. We spoke about open source, and we spoke about ARM technology. We spoke about the digital revolution, the leading edge, cutting edge, and bleeding edge. We spoke about NLP, natural language processing, microservices, containers. We spoke about where big data stands, where data science stands, and we spoke about IoT devices, and we spoke about 5G and supercomputers, and at the end, AI revolution. So with that, I'm pretty much done, and I have a link for the presentation available here. I don't know if this will be shared. Probably will be, but with that, this is my LinkedIn, my Twitter, and email, and I'm open for questions.
Yes, sir. So we'll send the PPT through mail, sir.
Okay.
Feedback along with the e-certificate. Sir, how RPA related with AI? One
So
question.
RPA is infancy of AI. RPA is actually programs, computer written code, which is basically scripted out and uh, called automatically. Okay, there is no AI yet. So RPA is trying to, for example, I give an example where you if there is an accident and someone calls in to make an insurance claim. So you call, and the call is a robot call, automated call, where it will ask you, "What is your name?" And then you provide the name. "What is your policy number?" And you provide the policy number. And you ask what the car is and where the accident took place. This is all through robotic call, and it takes in all this information. No human involved. And then what happens is it automatically creates a claim process. It will allocate an adjuster to come and check all this information based on a schedule and people availability. So it would automatically look into calendar and that and figure out that, and assign a adjuster, and then it will automatically create the claim in the appropriate software for the records keeping, and it will automatically email the person who is calling with the claim details. And if there is any manager involved and other things involved, it automatically takes care. So there is no AI technically involved. So what it is doing is there are small simple tasks which is a step by step task which is automated. So AI takes it to the next level, where you may be able to recognize, for example, based on the caller's voice, you may be able to recognize, okay, is he happy? Is he angry? And you may, based on that, you can figure out things. You could look at an image and do a facial recognition, understand if he's happy or not. And you could look at some other images and figure out what that image has and things like those are AI examples. Hope that makes sense.
Next question. Um, Alter ego designed about that, sir. Alter ego designed based on Stephen Hawking. Use device to explain the thoughts. So, can you explain about that alter ego? So, how it is used? Alter ego.
Well, alter ego, there's too much technical detail. I'm in fact not very, I don't know the depth of it. But all I know is it is developed by MIT. So it is an instrument that you attach to yourself, and it is able to figure out what you're thinking. Um, and then based on the thinking, using AI, it is able to give feedback to your brain. So it is something that is talking to your brain. It is an interface to human brain.
Yes, sir. So, can we do research like a research scope in open source?
Um, well, I don't really understand what that question means,
That is
but
research scope or publications. Like, can we do research on this open source software?
yes,
So,
yes, yeah, of course, yeah, you can. Like I said, there are millions of developers and millions of projects available. Yeah, you could study and do a white paper on that.
okay. So, will the open source be helpful for even a non-technical person?
Um, well, yes and no. Open source is actually mostly for technical people because it is related to code. But not only that, but it also has documentation. Documentations, for example, how to use the code, or how to build the code, or compile the code, how to install the software, and how to test the software. So these kind of documentations are already there. That is not necessarily a technical job. It could be someone non-technical who can go through the document and help improve and contribute to open source.
Yes, sir. So how can I ask, like how can it has been asked for using less RAM in high performance computing systems?
Well, like I said, now you have everything virtual. Um, in olden days, everything was run in bare metal. That means the whole physical box. You utilize the complete processor, CPUs available, the complete memories. Most nowadays nobody does that. So nowadays it's all virtualized. So we went through the VM world where you had virtual machines where you basically cut the CPUs and you say this VM would have this many CPUs and this much RAM. So you can slice and dice a physical machine into virtual machines, and that technology has changed. Like we saw what containers was, Dockers and things like that, which will give you even more fine grain level access, and it will tell you exactly how much memory you can use, exactly how much CPU you can use, exactly how much storage you can use.
Yes, sir. So we'll take up last question. Like what is the difference between cloud and edge computing? Cloud
Like I said, edge. Well, cloud is means data center, where it's a location where you have large amount of computers. So basically, lot more powerful than your computers at home. So those are arranged in something called racks. So you will have blades of computers, very high power ones, and a large amount of them. Hundreds of machines, thousands of machines. That is called data center. That is actually what is cloud. So cloud means is actually a group of a physical location where you have a lot of physical machines. Okay, um, which is shared between people who are using cloud. So basically, going back to the same virtual concept where you take the physical machines and logically slice and dice and provide that to the users. That is cloud. Edge is IoT devices. Those are the small ones like this. These are the tiny ones. These have CPUs in them, and these has memory in them, and has storage in them. And these can do compute power, just like your computers. These can do compute as well, but they are not really powerful. These are small devices. These can be utilized in industrial sites, near machines, and things like that. Is the purpose of IoT.
so you can stop the screen share, sir, so that what you have shown can be seen clearly. Yes, sir. Yes. So now
Okay.
we come to an end. Yes, sir. So we are happy to have a great session from you, sir, and having patience to address the questions and spending your valuable time for the participants. And we thank our department professor, Dr. Suresh Kumar, sir, for referring you for today's event. And definitely you made the session enjoyable. And we also came to know the future industrial opportunities and technology trends that we need to focus. So on behalf of Chennai Institute of Technology, we thank you for spending your valuable time. Thank you, sir.
Thank you so much. It's a great opportunity for me to really enjoy talking. Thank you all.
Thank you.
Thank you, sir. Thank you, sir. Thank you so much. We will meet in some other occasion. And Chennai Technology is also uh, eager to collaborate with you in forthcoming things. So thank you so much. We'll meet in some other occasion. Thank you.
Okay. Thank you.
Thank you.
Thank you so much. Thank you so much for all for being with us. So Chennai Institute of Technology is also, as Sir said, is introducing new courses in the as per the trends, how technology is booming. So we this year we have also introduced a new course called AI in data science, which is going to rule the world hereafter. So we are uh, taking care of introducing new technologies like this. So last year we have introduced biomedical engineering. Uh, that will be one of the great course. And to this time, we have introduced AI and data science, which is going to rule the world in the forthcoming stage. And Chennai University of Technology is taking this tireless effort to enhance the knowledge of faculty, researchers, and student community as a social responsibility as a engineering institution, So purely this effort uh, is being taken in different scenario under the guidance of Honorable Chairman Sri P. Sriram. And at this point of time, we would like to thank him for guiding us to move in the different scenario by conducting different courses. And Chennai University of Technology is also conducting international seminar, international workshops and conferences and faculty development programs along with the webinars. And from the coming 8th, so it is planned one webinar is going to be conducted in order to enhance the knowledge of circuit branch faculty members and even the students, those who want to learn the fundamentals of electronics and recent trends in electronics engineering can join the workshop. So already the advertisements, these things, registrations on roll, so you can register. And please keep on visiting our website chennai-technology.com/webinar or chennai-technology.com, or you can visit Chennai Technology in both Facebook and Instagram and LinkedIn to know more about the forthcoming webinars and forthcoming conferences and workshops and FTPs. Okay. So the forthcoming FTP faculty development programs that is scheduled for 1 week from the 5th from 8th onwards to enhance the knowledge of faculty members of all circuit branches, and even mechanics pupils can also participate in that to enhance their knowledge. And the faculties, those who are missed to learn, so you might have planned to study electronics, but you might have taken some other branches, so that you can also take part of that 1 week FTP. It's namely it is as FTP, but it is like a course. So whoever can join. But since the accreditation agencies are having some value, allotting some marks for the FTP, this has been named as FTP. But whoever wants to enhance their knowledge can take part of this course. And it is also my proud to announce we are conducting 2 days international seminars on advances in materials and manufacturing, which has been scheduled to be on 18th and 19th of this month. So eminent professors, Dr. Manoj Gupta, professor from NUS, he is well-known person in the materials around the world. So he has consented to be one of the expert member on the particular seminar. And also Dr. Subriya Ganguly, who is a well-known person in welding additive manufacturing in the world. So who is also going to be an expert member for the particular workshops. Okay. So apart from that, so a lot of conferences and workshops have been planned. So please keep on visiting our Chennai webinar. Will help you to know about forthcoming webinars and all. Okay. So thank you so much. Thank you. We will meet on some other occasion. Thank you, madam.
Thank you for all the participants.